Hello, good morning, everyone. Here we are once again with a new webinar. This is going to be the fourth one. And we have the sensors today. This Wednesday, we are going to talk about lighting gateways, the DMX and the RGB wide devices. And then next week, Monday, we will talk about the touch screens plus the SRKNX tool we use to program them. And on next Wednesday, April 29th, we will talk about web servers and the apps, the iOS and Android apps, and also about voice control via Google Home Assistant. Probably due to the succeed of these sessions and considering the interest we were talking about and your questions and so on, maybe we will organize one extra seminar, the eighth one, which will be focused mainly in the arithmetical and logical unit option we have in many of our devices. So probably we will organize it for Monday, May 4th. Anyway, I'm going to send you definitive confirmation, but probably on May 4th, Monday, we will organize this 8th seminar for the arithmetical logical unit. So of course, I'm gonna send you. It's gonna be here in the same room. I think it could be interesting for all of you. So anyway, I will send you definitive confirmation. And some people is asking about the already done webinars. Remember that you can find all of them already uploaded in our YouTube channel. Here in the presentation right now, you have the YouTube channel. So you can go ahead. During Andres' presentation, I will indicate in the chat the URL you can use to access directly to the YouTube channel. Anyway, if you open YouTube and you look for Ingenium SL channel, you can find it very easy, and all the webinars are there. We have them in Spanish and English, so you can go ahead with the English ones, and you can find them very easy. All of them are uploaded, and this one, the new one we are doing today, you will have the option to find them in 1 hour or so after we finish this. So nothing else today. Andres is going to explain you. He's going to explain you a while about all our sensors we have in catalog, features, ETS catalogs, and some presentations and some examples. Sorry. In parallel, Sergio and myself, we will be there in the chat trying to clarify some questions, and in case we have some interesting questions to discuss at the end, we will take notes and we will talk about that at the end. Okay, so it's going to be time for Andres to explain all you in detail. As always, if you have any questions, try to ask in parallel in the chat so we can clarify in live, or we can postpone your question to the end of the webinar. Okay, so welcome to all of you, and let's try to enjoy this new session today. Andres, all yours.
Well, thank you, Miguel, and good morning, everyone. Well, first of all, our mail contact. If you need something apart from the webinars, if you need more information, if you need more examples, if you need to ask us about anything, you can contact us in these two mails, the technical team one and also the export team one. And well, also our website, in which you can find a lot of information about our products. For example, about today's webinar, in the sensors. In each product, you can find the data sheet, the programming manual, and also the ETS application program. So in the programming manual, you can find all the information about the parameters, about the communication objects, and everything. I will try to explain everything today, but as you can see, it's a lot of information. So if you have any doubts, you can also look in these manuals. So let's come back to the presentation. And about our sensors, we have three different types: the SR sensor, the SIF sensor, and the SIFLUX sensor. The SR sensor is a hidden one. It is based on radio frequency technology, which allows it to pass through any kind of surface except the metallic surface, the metallic ones. So, you can install it above files or technical settings, in brick walls, wood walls, plastic walls, any board except a metallic one, because it will not pass through a metallic one. Then we have the SIF sensor, which is a motion brightness detector plus passive infrared sensor. It has two different channels, one the main channel and an additional channel, and it works with thresholds to control with the light level. It works with thresholds. And then the SIFLUX, that is an infrared movement detector, but it allows the constant light regulation. It also has an additional channel. It allows the constant regulation, as I told you, and it has an embedded temperature sensor. About the sizes and the colors, in the SIF version, we have the embedded version. You can choose between the white one and the black one, and we have the surface mounted one. For the SIFLUX, we only have in white, but we also have the embedded version and the surface version. I will show you both in the camera. Give me a second to activate it. Okay, so this one is the embedded one, the embedded mounted one. You see, it's really small, and you have the KNX connector in the top. Okay, so this will go. You only will see this when it's embedded. And then we have the surface one. Is this one? Okay. The KNX connector is inside. You have to remove the back side. You have to remove the back side to access to the KNX connector, and it will be like this. So it will be like this in the wall. Okay. Again to the presentation. And I don't have the hidden movement one here in my house, but you can find the size in the website if you need it. But as it will be hidden, it's not really important the size or the look of that sensor. Well, about the detection range for the SIF and the SIFLUX, it will be 5 meters diameter at a height of 2.5 meters. And for the SRKNX, well, you have a warranted detection range of 6 meters and 3 meters, and a maximum one for 12 meters, 6 meters. Okay. Then, what do we mean when we talk about work with threshold light levels? Well, we mean that you can choose a threshold, for example, 500 luxes, and the sensor will send orders when you are beside that level, when you are from 0 to that level that you have selected, to that threshold, and up to that threshold, it will not send orders. So, for example, in a corridor, if there is enough light, it will not send an order to turn on the light. If you don't have enough light, it will send the order. So that's the way to work with that sensor, with the SIF1 and the light measure, the brightness measure. Okay. Then with the SIFLUX, you have a different function. That is, you can select the brightness level that you want in the room, the light level that you want to have, for example, 800 luxes, and it will measure the light that you already have, the natural light or the light that you have in the room, and it will control another light to have the final level that you want in the room. So if the natural light changes, if the light in the room changes, it will also change the value of the controlled light to have always the light level that you want to have in that room. So that's the difference between the SIF and the SIFLUX sensor. The SIF cannot control the light to have always the same level. It can only work with a threshold. Okay, so depending on what you need in each room, you must select one sensor or the other one. Well, now we will move to the ETS to see a bit of the parameters and the configuration of that sensor. Okay, I have this small project with a SIFKNX, a SIFLUX. Sorry, I have some problems with my mouse. Okay, so this is the SIFLUX, for example. Okay. This is the SIF, and this is the SRKNX. That, well, it's the same catalog for the SIFKNX and the SRKNX. Well, different catalogs, but the same parameters and communication.
Andres, I don't know if all people is having the same screen like me, but I'm still frozen on the PowerPoint presentation.
Okay, let me change it. Now
right now we are in the ETS. Yes, right now we are.
Okay, sorry.
So you can start with this part right from the beginning if you want.
Sorry. Okay, so well, this is the catalog for the SIFKNX. This is the catalog for the SIFLUX. Okay, And this is the catalog for the SRKNX. For the SIFKNX and the SRKNX, we have different catalogs, but you will find the same parameters and the same communication objects in both catalogs. So let's start, for example, for the SIFKNX. And in the general parameters, you will find these parameters. Well, the first one is not used. The second one, the smoothing. Okay, this is what I will explain all of them in the presentation. Then we have for the SIFKNX, we have the brightness threshold, in which you can adjust the threshold of luxes that you want. Remember in the presentation that we see how it works with the thresholds. Then we have the sampling time. And no more for the SIFKNX, because as you can see, the last one is only for the SRKNX. It's not used for the SIFKNX. So in this tab, we have the smoothing and the sampling time. So what is the smoothing? Well, it's the value that represents the needed persistence of to detect a movement. Well, you can select it between 0 and 10. And the greater the value that you select, the more continuous the movement must be to detect a movement, to detect that movement as a real movement. We recommend these values for that parameter. If you want a movement detection to activate a light or something like this, you must set a 2. And for intrusion detection, for example, an 8 will be enough. And the sampling time. The sampling time represents the number of samplings taken to evaluate a detection. Okay? You will understand this better in this example. Okay, the sampling time is this. Well, in this case, 16. It's the time in which the sensor evaluates if there is a movement or there is not a movement. And the smoothing is the number of pulses that the sensor needs to detect in that sample time to consider a movement. So, for example, if you go to the first sample time, you see that we have 2 pulses detected. So if the smoothing it's only 1, it will consider it a movement. If the smoothing is 2, it will also consider it a movement. But if the smoothing is 3, it will not consider this a movement. So you will need more pulses, you will need a more continuous movement to detect it as a movement, like in the third sample time. Okay. So you have more descriptions here. Well, the telegrams of detected or not detected will be sent after the sampling time. So if you set a big sampling time, the sensor will respond slower. Okay. So this is only to configure how the sensor detects or not detects the movement. Let's move to the other parameters. Okay, we have 2 channels, as I told you in the sensor description. And for each channel, channel, you can choose which telegrams do you want to send. Okay, you have the bit telegrams. You will see in the communication objects. Okay. The bit ones, you can choose to send a 1 or a 0 when it detects movement, and a 1 or a 0 when it it stops the movement detection. You can also send temperature telegrams through this communication object. And you can also send, byte telegrams, okay, through this communication object. Sorry, the first one. Then you can choose to send telegrams when there is a motion detection, to send telegrams after the motion detection, and that means when it stops detecting the movement. And you also can choose to send or not off telegrams when the channel is disabled. When you disable the channel, if you want to send an off telegram or not. Then for each channel, well, these parameters are for both channels. You have the same parameters in both channels. And you also have the delays. Well, these are delays to enable and disable the channel. That means you send the order to enable the channel, and it will take this number of seconds to really enable the channel. And then you have the channel shift off delay with red trigger. That is because when you go into a room, for example, with a sensor, the sensor detects you in the room, detects the movement that you make when you are entering the room. So it sends, it sends this telegram, the motion bit telegram, also the motion temperature telegram, and the motion byte telegram, if you have all of them activated. It sends that telegram, the motion byte. If it continues detecting you each second, it will remain sending that telegrams without no stops until it stops detecting you. So if you only want to send the telegram one time, you enter in the room, you want the on telegram, and you only want another telegram when you leave the room and it stops detecting for some seconds. You must set here, for example, we'll set 20 seconds. Problems with my cable and I don't know why. No. Well, imagine that we set here 20 seconds, okay? So when we enter the room, it will send the on telegram, the telegram that we configure as here, a 1 or a 0, and then it will take 20 seconds to send another telegram. So if in these 20 seconds the sensor detects us again, it will restart the 20 seconds. Okay, it will start counting again the 20 seconds. If after that 20 seconds it doesn't detect us, it will send the off telegram. Okay, it will send the other telegram, this one, no motion bit telegram. So for example, in a light, the behavior will be, you enter the room, it sends a 1 to the light, so it turns on the light. And if you leave the room and it doesn't detect you in 20 seconds, it sends the 0 telegram, it turns off the light. Well, that's all about the SIFKNX sensor. I don't know if there are any questions.
Yes, Suki is asking for an example about how to link one sensor with one push button to manage a light in a toilet. But I think it's one of the examples we have today.
Yeah, we have, this is exactly one of our examples today. So okay. We will move at the end
perfect.
of the...
So Kevin is asking for the same, so let's wait till we present that example. And then, in case there are still some doubts or questions, we can clarify deeply. But I think it's going to be resolved after the example. Okay, so let's wait till that time.
So let's move to the SIFLUX. This one, the SIFLUX parameters. Okay. Well, in the SIFLUX parameters, you have the motion sensor response. The motion sensor response are the detection softening of the present sensor. So it's the value that represents the detected movement per system. If you set a sensitive value, a very small movement will generate a detection. If you select a greater value, a harder value in this case, it will need a more continuous movement to detect. Okay, so we recommend for a movement detection to turn on a light, we recommend the normal. For example, for intrusion purposes, we recommend the hard one. Okay, so it's easier to configure that motion sensor. And then in this sensor, you have the possibility to configure the constant light regulation to make this behavior and regulate a light to have always the same light level in the room. You can configure that constant light regulation independent to the movement, triggered by motion only with channel 1 or only with channel 2, or in this one with both channels. Okay, so let's move, for example, to configure one of the channels of the motion. In the general parameters of the motion channel, you can select if you want telegrams when there is a motion detection and after the motion detection. Okay, you want or you don't want that telegrams. And then you can choose the polarity to lock or unlock the sensor. If you lock the sensor, it will not send orders to the light, or it will not send telegrams through its communication objects. You can also choose the status after the download of the application. And if you want to send a no-motion telegram after the channel lock, that means, you enter the room, you are into the room, the sensor turns on the light, and while you are into the room, you block the sensor, okay, and you leave the room. If you set this parameter as yes, if you want to have no motion telegrams after the channel lock, the sensor will send the after motion detection telegram, the no motion telegram. So it will turn off the light. Also, the sensor was locked, and when you enter again the room, it will not turn on the light because it's locked. But it will turn it off if you set this parameter. Then about the telegrams, you have the same telegram as in the SIF sensor. You can enable or disable the telegrams. You have the 1-bit telegram, the 1-byte telegram, and the 2-byte telegram. And then you have the delays. Okay, then same delays as in the other as in the other sensor. You have the channel shift of delay, which you can override or not with a communication object. You also have a delay for the lock of the channel and a delay for the unlock. Okay. Then about the constant light regulation. Well, you have two types of regulation if you want to make a relative regulation or an absolute regulation. You can choose the minimum value for the regulation. That means that maybe you don't want to turn off the light at any time. You always want to have like a 10% in the light, for example, in a corridor or something like this. Maybe you want always to have some light in your controlled light. So you can choose the minimum value here. Okay. And then you can control an additional light line. Okay. I have problems with my mouse. I don't know what's happening. Okay. Sorry. I cannot select the additional lifetime. Well, in the additional lifetime, you will be able to control an extra line, okay? And you can select the offset that you want, the offset value that you want for that line. So you can, for example, in the example that you see in your screen, we have a sensor here. We are controlling the line 1 to have a level of light. And we can control also the line number 2 with an offset. That means that if the sensor is calculating that we need 100% in the line 1, it will set 100% minus the offset that we select in the line 2. In this case, 70%. Okay, so it's to control another line with an offset, with a different value than the value that we calculate for our main line. Well, then you can select when do you want to send the telegrams. Each time there is a change in the calculations of 1%, 3%, or 6%. And you can also select the time between the telegrams, the regulation telegrams. Then you can allow a deviation in the set point, to make less calculations and to allow a bit of a margin between the set point and the real light in the room. And well, the initial set point that you want, because the set point, you can enter it in this communication object. So at the start, when you program the device, you will have this value, and then you can change the value through this communication object. Then the object format for the light, if you want it with 2 bytes flow up with a DPT of 9.004 or the other DPT, depending on on your project and on your needs. And about the brightness sensor, well, you can calibrate it through the parameters, and it also allows you to override the calibration through the object. So in this object, this one, it will give you the actual luminosity. And if you write through this object a new luminosity, you will calibrate the sensor. So from the moment that you send a new level of light here, it will take that level as the actual level. Well, that happens only when you enable this parameter. If you disable the parameter, you will not be able to recalibrate the sensor through the communication object. And then you can select when do you want to send the measure luminosity to the bus. If you want to send it cyclically, when it changes when it changes a value, or both. Okay, that's the options to send the measure light into the bus, to the KNX bus. And then finally, we have the possibility to change between the automatic and the manual regulation. This is because maybe you have a regulation light in a room, a dimming light. You are controlling the light with the sensor, but suddenly you need to control the light from a push button, or you want a different level in the light. So you can change to the manual mode and control the light without the sensor, okay? Without depending on the level of the set point that you set in the sensor. So, well, you set the polarity of, if you want the automatic or the manual with the 0 or the 1. Activate the auto or the manual, the mode, you can select it in this communication object, and you will have the information in this other communication object. And then when you make the change from auto to manual, you can choose to have stop without change. So the dimmer will start in the actual in the lighting level that you have at that moment, or you can choose another value. So the dimmer will move to that value, and then you can change that value with your push buttons, or you can change it manually. And same thing when you change from manual to auto, to the automatic mode, from the manual mode to the automatic mode. Here you select which value you want to start with. And then you have this option, the bypass objects. I don't know what happens with my mouse. I cannot select I cannot enable these options. Okay. So if you enable this bypass object, you can send here to this communication object values, and the sensor will change automatically to manual mode. So without sending anything to this mode, a communication object, if you send a value here, for example, you send here the manual control value, you send 80%, the sensor will send to the light regulation, to the dimmer, the value that you have sent here, okay, automatically. And the sensor will not recalculate new values, because it will be automatically in the manual mode. it will change automatically to the manual mode each time you send something to one of these three communication objects. And now it lasts only the temperature sensor. Okay. The temperature sensor, you can calibrate calibrate the sensor, and you can choose when do you want to send the values. It's time, or if you want to make it when it changes, to send it when it changes or value, or both. Both. When it changes, or it's time. And that's all about the parameters. Now we will move to make some examples, and I think that
Andres, we have a couple of questions about. One of them is about how to control one circuit from more than one sensor. We have been talking about master and slave mode in the chat. Are you going to explain the examples, or do you want to go ahead now with the master and slave?
Well, maybe it's better to make first the examples, and then we can move to the master and slave one. We can also make an example with the master and slave one.
Okay.
It's okay for everyone, I mean.
Okay, because then there is another question related to lock or unlock the sensor when you are managing from a button. We are clarifying in parallel with Sergio via chat, but maybe we can go ahead with examples, and then in case there is any doubt,
we will lock the sensor and unlock it from a push button. So maybe this example will clarify many things.
Perfect. So let's finish with the examples, and then in case there is still any question, or we need to clarify something else, we can go ahead.
Okay, so we will start with this example, in which we will turn on and off a light with a sensor and a button. When we turn on the light from the sensor, we want the light to turn off after 10 seconds without movement detection. But if we turn on the light from the push button, the light must be on until we press again the button. Okay, so that's why we are going to lock or disable the sensor when we press the button. When we press the button, we will disable the sensor to avoid the sending of a 0 when it stops detecting movement. So we will do it with, well, I don't know why I have many problems with my mouse, but maybe give me a second. Still have problems. Well, okay. So in this sensor, well, in the SIFKNX, well, I will not touch anything in the general parameters. Do you hear me?
Yes, we can. Yes, we can. Right now, we cannot see the image, but yes, we can hear you.
Okay, let me share it again. I'm having technical problems. A second. Okay, do you see the screen now?
Yes. Yes, we are.
Okay. Okay, so let's go. Okay, in the general parameters, we are configuring the detection of the sensor. Well, in the here in the presentation, I told you that for a light, here, sorry, here. For a light, to activate a light, a smoothing value of 2 and a sampling time of 16, and it's enough. So we have by default these two values, okay? So that's done. In the telegrams, when the sensor detects movement, we want to send a 1 because we want to activate the light. So this is okay for us. And we want telegrams after motion detection because we want to turn off the light automatically when it stops detecting movement. We don't want off telegrams when the channel is disabled because we want that when we disable the channel, when we disable the sensor, we don't want more telegrams. We want to have the light on until we press again the button. So we can disable that function. Then delays. Well, we don't want a delay in the enable or in the disable of the channel, but we want a 10 seconds delay. We need 10 seconds. Change this. Well, I have problems. You must forgive me. I have problems with my keyboard and my mouse, but here we must set at 10 seconds.
Andres,
Okay.
maybe you can try using the arrows on the right with your mouse on the ETS catalog. Using
that's true.
Yeah.
Thank you,
if you have problems with your keyboard, maybe you can use this option.
Yeah. Thank you. Okay, so we set the 10 seconds value because we want to have the light on for 10 seconds of no detection movement. Okay, so with this value set to 10, the sensor will be detecting us and the light will be on. And if the sensor doesn't detect any movement in 10 seconds, it will send the off value. So that's what we need. And we don't need the channel 2 in this case. So let me delete all this. Okay, so now we need to link this communication object, which is the communication object that through which the sensor sends the on and off value with the light. Okay, so this is our motion detection telegram. Oh, I cannot write anything. Okay, well, sorry about the technical problems. So we must link this motion detection communication object.
Andres, you also have the Windows option to open a keyboard on the screen, so maybe you can use that option.
Which option is this?
If you go ahead in the Windows button, and if you text there teclado, you can open it.
I cannot text here anything. I don't know what happened with my keyboard. Well, maybe it's enough with this. I mean, you have to link this communication object.
If you try to open the Windows button over there in applications, maybe Windows accessibility, accesibilidad de Windows. Tiene que ver. Teclado en pantalla, ahí lo tienes.
Okay. Oh, This is enough. Okay. So we go to link this one. We can link it with new. This is true. It's not working.
Andres, we can do one thing. You can restart your computer and we can connect again in 2 or 3 minutes. I think it's going to be better.
I will restart. Sorry about the technical problems.
Okay, go ahead. Go ahead. We will be back in 3 minutes as soon as Andres is connected again. Meanwhile, well, the options we have are related to the to the examples we have pending. So in case you have any other question right now, we can clarify. If not, let's wait for 2 or 3 minutes till Andres is connected again. Well, while Andres is trying to connect again, I have one request from Rafael Marculescu from Romania to participate and to talk about as an example. So, Rafael, you can go ahead. Your microphone is open.
Hello, everybody. I hope you can hear me.
Yes, yes, we can.
Okay, and happy Easter for the ones who have these days, the Easter, Paște fericit in Romanian. It's regarding the functionalities when you are trying to use the constant lighting. To create a feeling, a normal feeling when you switch from the bottom, you initiate the constant lighting, and then when you finish this constant lighting functionality, in practice we use like this. When you switch from auto to manual, that means you intend to switch off the lighting. That means you want to switch off. We put the level like 0% to create that feeling that immediately you press the button, the constant lighting functionalities is off, and the lights will confirm you by switching off 0% the lighting level. And when you switch on the constant lighting, despite the fact that maybe you need to the lighting to increase only up to, let's say, 30% or 50%, first time when you switch on and you start the constant lighting functionality, the level to be 100% to create the feeling that the lights are on, and then let the sensor to automatically decrease the level that it's normal and it's computed by his internal regulator. So this was my comment, my advice based on our experience with this constant lighting. Also, a comment for us, it's very useful to use the 1 byte command object, the 1 byte, because we can see also in a group monitor how much it's the value computed by the sensor, and then we can see if the dimmer it's also send the feedback with the same value, so we can be sure that the regulation is working fine. I know that this constant lighting is not so easy to understand and to be put in practice at the first time, but after the first successful experiment, you will enjoy it and you will use it more and more. Thank you for your attention, and have a nice day, everybody.
Thank you so much, Rafael, for your point of view and your suggestions. Really appreciate it. We also have Suki from Israel waiting to talk and to share with us his comments. So, Suki, your microphone is open now.
Hello, good morning, everybody. I have a question, not share a comment, but a question about the sample. I know Andrea didn't finish his sample, but I have a question. If I have the same issue like he put in the sample, I go inside to a bathroom and the light turn on, for example, 10 seconds. After 5 seconds, I go out and I turn the light off by the push button. And after 2 seconds, I go inside again. What is going to happen? I understand the motion detector is not going to work because it's still in the 10 seconds that I put him. Is there any reset that I can do when I send the off from the push button to the motion detector? This is my question.
Okay, so I think that question is much better for Sergio and for Andres to answer. So just give us some seconds till Andres is in and Sergio is also there to try to answer you. But mainly your question is related to the combination between push button, presence detection, and one light the circuit, which I think is the example that Andres was trying to explain.
Yeah, but I think, okay, maybe we'll finish and I will see, because I think this issue, I tried many times here in our project and it's not working so good. So maybe I did something wrong in the ETS. I don't know.
Okay, so let's see if we can clarify with the example that Andres is waiting to complete, and then we will go ahead, okay?
Okay.
Okay, Andres is gonna be in a minute, okay? So just 1 minute. Yeah, here we are. It seems Andres is already in. Audio activated.
I'm in. Sorry about all these technical problems. I think now everything is solved.
Is your
keyboard
running?
Yeah. Now.
Okay, right now we can see your screen, but like some foggy. It's not the resolution is not so good.
I don't change anything. Maybe something in the Zoom. So you see it now?
We are seeing the camera right now.
And now, are you seeing the ETS?
No, right now is the camera I seen.
Now? Now are you seeing the ETS? Sorry about all this.
Let's go ahead. Let's go ahead. Come on.
Let's go. Okay, we are doing the example, the first example, in which we turn on the light from a sensor, and we also turn on and off the light from a push button. So we have configured the sensor, the delay of 10 seconds to have the turn off Telegram after 10 seconds of non-detection. And we must link the motion detection of communication object. Okay, this is motion, Telegram. Motion bit Telegram. Okay. We will link this communication object directly with, well, I have an actuator here with a binary output to connect a light. So we must link the communication object in the sensor with the light direct. Okay, so now we will have the first part of the example. The sensor will turn on the light when it detects movement, and after 10 seconds of no movement detection, it will turn off the light. Okay, now we need to turn on the light from a push button and disable the sensor to make the light remain on until we press again the sensor to turn it off and reactivate the sensor. So, well, I will use a qubit. If you need more information about the qubits, you can watch one of our webinars. I think that is the second one, which you can find in our YouTube site. And we can turn on and off. Well, if we go to the parameters, the bottom one, we can make a switch to send a 1, and then the next time we press a 0, then a 1, etc. So if we link the bottom one to 0, 1, for example, 1, and we link it directly with the actuator, with the switch on off of the actuator, we will turn on and off the light from the push button. Okay, so this is the button one. Now we are sending the on-off orders to the light, to the actuator, which controls the light correctly, but we are not locking or disabling the sensor. So we must act on this communication object to enable or disable the sensor, to avoid the sensor send the off order to the light when we turn on the light from the push button. So to disable the sensor, we need a 0 here. Okay, the sensor is disabled. This channel of the sensor is disabled with a 0. So here, when we turn on the light, we are sending a 1. So with this telegram disable the sensor, we need to change the 1 to a 0, and the 0 when we turn off the light and sending a 0, we want to enable again the sensor. So we, with a 0, send it from this communication object. We want to have a 1 in this communication object. So we are going to set a gate, a logical gate. It's a NOT gate with an input with a size of 1 bit, and an output also with one bit. To make that the orders that we send here, to transform the 1 to a 0 and the 0 to a 1 to enable and disable the sensor while we are turning on and off the light from the bottom. So well, I have it here. In the input 1, we need to set to link, the button, okay, the button telegram, and we will link the output, that is the opposite of the button 1. We will link this communication object with the enable disable of the sensor. So now when we enter the room, if we don't press the button, the sensor will detect us and will send a 1 through this communication object to activate these outputs and turn on the light. And then we will leave the room, and after 10 seconds without movement detection, the sensor will send a 0 through this communication object. So the light will be turned off. If we enter the room and we press the button, we press that first button, we will send a 1 through this communication object, 201. So we will have a 0 here, because here we have the opposite. When we send a 1 through the button, here we have a 0. So the sensor will be disabled. So we will not have the no motion telegram. We will not turn off the light from the sensor. And we will need to press again the button to have a 0, send a 0 to the light to turn off the light, and enable again the sensor, because with a 0 in the button, we will have a 1 here that will enable the sensor. Okay, that's the first example. And in the second example, we want to control a light to have always the same lighting level in a room. Okay, so we have a dimmer here. We will speak about dimmers in our next webinar on Wednesday. But well, in the dimmers, you have the on-off object, and you have the possibility to select directly a value from 0% to 100% to select the light level. So we will act with the sensor on that value to have always the same light level in the room. Okay, so if we go to the sensor, this time we need the SIFLUX sensor, because we want a constant regulation. So we need to, in the parameters, okay, we will make it movement independent. We always want to be regulating the light. We don't need the temperature sensor. And we will not use, in this case, the motion channels. It will be working always. Okay. So now, constant light regulation parameters. In the general, we will use the absolute communication object. We will use this communication object to control the dimmer. Well, we will set, for example, this minimum value of 10%. We don't have any additional light. The regulation steps, okay, 1%. Okay. Time between telegrams, we will set 5 seconds, for example. We will allow the deviation of 100 luxes. It's okay. And the initial luminosity set point, well, we will set, for example, well, set 18, that is 800, sorry, that is 800 luxes, okay, because you have to multiply this value with 10. And then, the object for the luxes, it's okay to have it in DPT9. About the brightness sensor, well, we will not calibrate it. We want to send the changes of 20 luxes, for example, and it's 60 seconds. It's okay. And we will enable the manual objects to show you how this works with the manual objects. Okay. So we have the parameters. Now we must link these objects. We have the measure luminosity. Okay, this is important to know. So this is 0, 0. This is the measure. Then the set point, we set for the start 800, but maybe we want to change it or we want another level, so we will link those. Then we have the on-off of the regulation, and we have the absolute regulation. We will link the absolute regulation with the dimmer. We will link this regulation with the dimmer, with the value of the dimmer. Okay. So now, with the measured luminosity and the set point, the sensor will calculate the regulation level that we need in the room. And we can give the sensor this information, the real value of the dimmer, because some dimmers take some time to reach the lighting level. So with this feedback, the sensor will know the exactly lighting level of the dimmer. So we must link the value status, the status of the dimmer, link it with the feedback in the sensor. Okay, so now the sensor has all the information that it needs to control the light. Now imagine that we want to have a concrete value. For example, we have also this cubic in the room, and we want a button to turn automatically the value, the dimming value, to 100%. Okay, automatically 100%, and we don't want the sensor to recalculate the light level that you must have to reach the set point. Okay, you want 100% without no calculation. So in the cubic, we will configure a button to send 100%. Okay, and some people make this error because if you link this communication object directly with the dimmer, okay? You send directly from the button to the dimmer, you will have the 100%, but then the sensor will recalculate the light level that you need and will send another order to the dimmer. So the sensor will change that 100%. If you want to have the 100%, you must link this button number 2 instead. You must link the button with the bypass option of the sensor. Okay, this manual control value. Why? Because if you send the 100% to this communication object, the sensor will change to the manual control, will change to the manual mode, okay, automatically. It will change to the manual mode, and it will send through this, through this communication object, it will send the value of the button, this value, the value received through the communication object. So it will send the 100% that we want, and as it changes automatically to the manual mode, it will not make more calculations, and it will not send any other telegrams to change the regulation level. So the 100% will remain in the dimmer. Okay, and well, that's all about the examples. Now, if there is any doubts or if you want me to make any other example.
Maybe you can explain something about the master and slave mode.
Okay.
For the pending question we had.
Yeah. Okay. So
the idea of the master slave is to control one circuit from more than one sensor. So that's when we use the master and slave mode.
We will set 2 different sensors at the end of the project. Okay. And another actuator to control it. All right. Okay. So imagine that we want to control a light in this actuator. Okay, this light that we have connected in the output number 1 with these 2 sensors. We can use one of them as a master and one of them as a slave. So imagine this one. We can link the detection communication object. This one, this is the first detection. Okay, and we can, instead of link it with the actuator, we can link it with the master trigger of the other sensor. Okay, so when this sensor detects any movement, we'll send a 1 through this communication object through group address 400, and if we link that group address with the master trigger, this sensor, although it doesn't detect any movement, will be activated, will send the value through this communication object. So we can link this. So if the sensor receives a 1 through this communication object, it will send a 1 through the motion detection. It's like if it have detected movement. Okay, so we can link this communication object for, well, the group address 401 with the light. So now, if the first sensor detects movement, we'll activate the second sensor, we'll make the second sensor as if the second sensor have detected movement. So the second sensor will send a telegram through this communication object. And as we have it linked with the light, it will turn on the light. Also, if the second sensor detects movement, it will send the telegram through this communication object. So it will also turn on the light. So that's
yeah, and you can have as many slaves as you want. I mean, if you have a long corridor with one lighting circuit and you have 3-4 sensors along the corridor, in this case that Andres is explaining right now, you just need to add, for example, 2 more sensors, and those sensors are triggering via master trigger, the group object number 4. So through the group address 400, we can send also an activation to that sensor. So in that case, 3 sensors, 3 slave sensors were pointing to the master, and the master is in charge of activating or deactivating the lighting channel. But only the master is in charge of activate or deactivate the channel. The role of the slaves is only to retrigger or not the master, but nothing to do between the slaves and the final actuator. I think it's clear right now at this point. In case you have any other question or whatever, remember, feel free to text us or to let us know. Suki, what about your question? Is it already clarified or not? I can activate your audio in case you want to participate.
Yeah.
Let us know if it's already clarified with Andres' example or you need some more info.
I think it's not so clarified. I want to ask her again.
Okay.
In a different way.
Okay.
I have a toilet with a motion detector and a push button outside. I go inside, the motion detector open the light by himself, for example, 10 minutes. After 5 minutes, I go out and I turn off the light from the push button. After 2 minutes, I'll go inside again without open the light with the push button. The motion detector need to open the light. Is it going to open the light because it's still counting the 10 minutes and down? Is it clear, my question?
It is. For me, it is. Andres, did you get it?
Yeah, I understand what Keita means. Let me think about
Suki,
it.
it was Suki. Okay.
Ah, it was Suki. Okay. Okay. So, well, I have to think about this concrete example. So you need to turn on and off the light from the sensor or from the button, but you always want to to have the sensor activated and to make the light automatically off after some time.
It depends. Sometimes from the push button, sometimes from the motion detector. It depends. It's like a public toilet. It depends who is using it. Sometimes they're using it from the push button, sometimes from the motion detector.
Okay, so maybe I can send you the example later because
Okay. Because this is something that we use a lot of. This option we use a lot of time here, and all the time I have this issue and the problem.
Okay, I think
I
we
need
can
to think about it for some minutes, but I can send you in a few minutes the example.
Thank you.
Yeah, and Sergio is sending like a suggestion via chat. Anyway, we will prepare an example and we will share it via our website. So you will have the option to download it already configured. So I think it's going to be more useful. Anyway, we will send to you via email the example about how to do that.
Great.
Well, I don't know if is there any other question or not about all this. In case you have any other question, let's wait for a couple of minutes and we will check the chat to see any other question. If not, we can already finish the webinar. So let's wait for a couple of minutes and then final conclusions. Yeah, I can see some comments from Sergio about the solution for the Suki's example. Sergio means, Sergio is talking if it's clear or not. I think it's clear, Sergio. What Sergio means is that when you are leaving the bathroom and you are switching off the light from the push button, the sensor will think that the countdown is done. If I'm if I'm reading correctly what Sergio means, which means is that when you leave the bathroom and you press the button, the sensor is gonna receive also the telegram to finish the countdown. Am I right, Sergio? Yeah, exactly. If you write a 0 in the master trigger, the communication object that Andres explained in the last point, the sensor is going to think that the detection is finished. So the next time you enter in the bathroom without activating or deactivating via touch button or touch panel, the sensor is going to detect you again, even if it's on that 10 minutes countdown that Suki were explaining, because when you press in the push button, the countdown was automatically finished. So yeah, the next time you enter the bathroom, the light is going to be turned on automatically without any problem from the sensor option. Anyway, we will generate an example and we will share with all of you who are interested, and also we will put it, we will link it in our website. Well, so far, yeah, Andres is showing you in the screen how to use this option. Okay, well, it's 11:40 here in Spain, 1 hour 40 minutes, including all technical problems we have had today. I apologize about that. I'm really sorry about that. But I think the all these things we have and all the examples we have been talking about have been quite interesting. We will share the presentation online right now, and we will also upload all the examples, presentation, and so on to our website. So feel free to check our online channel, and feel free also to visit our website where we will hang all this information. Okay. See you next Wednesday with lighting gateways, DMX gateway, and RGB wide device. Okay, so thank you to all of you for the patience and for your participation, and hope to see you next Wednesday. Okay, thank you so much to all of you.